Exploring the infinity of the universe has fascinated philosophers for centuries, shaping human thought about the cosmos. In the 16th century, Giordano Bruno introduced the revolutionary idea that space was infinite and filled with stars and planets. Bruno challenged the geocentric view of the time, proposing that the universe had no center and that there were countless worlds like Earth. His bold vision not only expanded human understanding of the cosmos, but also influenced future scientific and philosophical investigations into the infinity of the universe and the possibility of life on other planets. Imagine the mind-blowing realization that our planet might just be one of many in an endless sea of stars. In contrast, 17th century English philosopher Thomas Hobbes took a more cautious and skeptical approach to the concept of infinity. Hobbes argued that speculating about infinity was a futile exercise, given that the human mind, limited in its capacities, could not truly comprehend it. He believed that pondering infinity served no practical purpose, reflecting a skepticism that still permeates parts of modern philosophy and science, where infinity is often viewed more as a theoretical concept than a tangible reality. It's like trying to understand the internet by looking at a single web page. There's just so much more out there. These philosophical ideas from Bruno and Hobbes continue to influence contemporary thought about the universe. Bruno's expansive vision encourages an open-minded and broad perspective, essential for modern astronomy and the search for extraterrestrial life. On the other hand, Hobbes's skepticism underscores the necessity of practical, empirical observation in science. Together, these philosophical perspectives shape a balanced view of the universe that combines wonder and speculation with critical analysis and rigorous observation. It's a cosmic dance between the dreams of what if and the realities of what is, helping us navigate our quest for knowledge about the infinite. The infinity of the universe can be deeply explored through mathematical concepts that challenge our conventional understanding. One pioneer in this field was Georg Cantor, a 19th century German mathematician who introduced the idea that there are different kinds of infinity. Cantor demonstrated that while the set of whole numbers is infinite, the set of real numbers, which includes all fractions and irrational numbers, is even larger, representing a different and bigger kind of infinity. His theory was revolutionary, challenging traditional notions of size and quantity, and offering a new perspective on infinity in both mathematical and cosmological contexts. Imagine trying to count forever and then realizing there's an even bigger forever out there. It's infinity squared. Another fascinating concept that illustrates the vastness of the universe is tree theory, introduced by physicist Antonio Padilla from the University of Nottingham. This concept involves creating the largest possible numerical tree, starting with a tree that has only one seed, and growing exponentially with each subsequent level. Tree 3 exemplifies how mathematics can generate immeasurable numbers and stretch our imagination. The complexity and scale of these numbers help convey the immensity of the universe, making us think about infinity in ways that go beyond our everyday experiences. It's like playing a video game where the levels never end, and each one is crazier than the last. These mathematical concepts not only challenge our understanding, but also help us visualize the enormity of the cosmos. By considering Cantor's different types of infinity and the enormity of tree 3, we begin to appreciate the true scale of the universe. Mathematics, with its ability to handle the abstract and the immeasurable, becomes an essential tool for exploring and understanding infinity. It allows us to conceive and work with ideas that are far beyond our direct perception, revealing a universe that is both immensely vast and infinitely complex. So next time you struggle with math homework, remember, it's not just about numbers. It's about understanding the universe. Extreme physical phenomena like black holes and white holes offer a unique window into understanding the infinity of the universe. Black holes, for instance, are regions of space with such extreme density that not even light can escape their gravitational pull. These singularities form when massive stars collapse under their own gravity, creating points where the laws of physics as we know them cease to apply. The existence of black holes forces us to rethink fundamental concepts of space and time, as within a black hole, time can slow down and space can warp to the point of seeming infinite. Imagine a place where your GPS just gives up and says, "Good luck." In addition to black holes, theoretical physicists have proposed the existence of white holes, which would be, in a sense, the opposite of black holes. While a black hole absorbs everything that crosses its event horizon, a white hole would theoretically expel matter and energy. Although white holes have yet to be observed, their theoretical existence challenges our understanding of entropy and thermodynamics. Some scientists suggest that white holes could be connected to black holes through Einstein-Rosen bridges, commonly known as wormholes, creating tunnels that could link different parts of the universe, or even different universes. It's like finding a secret passage in a video game that takes you to a totally different level. Studying these extreme phenomena helps us understand the infinite nature of space and time. Black holes, with their crushing gravity and relativistic effects, and white holes, with their theoretical properties of expelling matter, represent the limits of our current knowledge in physics. They force us to question and expand our theories, such as general relativity and quantum mechanics, in the quest for a deeper understanding of the cosmos. These cosmic objects are like natural laboratories where we can test the fundamental laws of the universe under unimaginable conditions, revealing new facets of the infinity of space-time. So, next time you feel like you're in a black hole of work, remember, it could be worse. You could be in an actual black hole. To explore the vastness of the universe and understand its infinity, scientists rely on advanced technologies and scientific methods. Powerful telescopes like the Hubble Space Telescope and the recently launched James Webb Space Telescope allow us to observe galaxies and cosmic phenomena at unimaginable distances. These instruments collect light and other types of radiation from distant objects, providing images and data that help astronomers study the structure and evolution of the universe. With these telescopes, we can see galaxies that existed billions of years ago, essentially looking back in time to observe how the universe has evolved since the Big Bang. It's like having a time machine, but without all the messy paradoxes. In addition to telescopes, scientists use standard candles and standard rulers to measure cosmic distances accurately. Standard candles, such as type Ia supernovae, are stellar explosions with predictable brightness. By measuring their apparent brightness, astronomers can calculate their distances since brightness decreases with distance. Similarly, standard rulers, like baryon acoustic oscillations, help map the distribution of galaxies across the universe. These techniques provide a way to measure vast cosmic distances and help determine the universe's expansion rate, crucial for understanding its infinity. Imagine measuring the distance to your favorite pizza place, but on a cosmic scale. These technological tools and scientific methods not only expand our understanding of the universe, but also allow us to test cosmological theories. Observations made with advanced telescopes and precise cosmic distance measurements enable the verification of models of the universe's formation and evolution. For instance, the discovery of the universe's accelerating expansion, which won the Nobel Prize in Physics in 2011, was made possible by studying distant supernovae. So, the next time you look at the stars, remember that scientists are out there, measuring, observing, and sometimes scratching their heads, trying to make sense of the cosmic puzzle. The infinity of the universe opens up an enormous field of possibilities for the existence of extraterrestrial life. Just think about it. Billions of galaxies, each with billions of stars and planets. That's a lot of real estate for life to develop. Scientists have already discovered exoplanets in habitable zones, where conditions might be right for life as we know it. It's only natural to wonder if we're truly alone, or if our cosmic neighbors are out there somewhere, perhaps watching our cat videos from light years away. One of the most intriguing signals in the search for intelligent life is the wow signal, detected by astronomer Jerry Ehman in 1977. This signal, lasting a mere 72 seconds, was incredibly strong and unlike anything we'd ever seen. Imagine getting a phone call from an unknown number and then never hearing from it again. It's that level of mystery. Although the wow signal hasn't been repeated, it continues to spark curiosity and hope. Could it have been an intergalactic hello? We may never know, but it certainly keeps the imagination alive. The theory of the infinite expansion of the universe adds another layer to our quest for extraterrestrial life. If the universe is endlessly expanding, the odds of life existing somewhere out there increase. But here's the catch. The vastness of the cosmos makes it incredibly difficult to detect and communicate with any potential civilizations. Programs like the Search for Extraterrestrial Intelligence, SETI, use powerful radio telescopes to scan the skies for signals, but it's like looking for a needle in an ever-growing haystack. So, are we alone in this massive universe? Or is someone out there also trying to figure out how to fix their Wi-Fi? Only time and more sophisticated technology will tell. Sign up and join us.